we need to come up with the solutions to provide our decision support when and where and how to maintain our infrastructure materials. For the next generation infrastructure, we're going to design new materials, make it more durable, more sustainable, and more resilient to those challenges. Currently, I have 4 students working with me. Each one is in charge of a specific area. Asif is coming up with both chemistry and physics-based model. It's developing partial differential equations to include different phase change and reaction and physical expansion and cracking and damage processes. One big nuclear power plant was decommissioned within like 15 years because of major reason is ASR damage. So this one creates a lot of problem. Generally for other degradation modes of concrete, you can block it, you can stop it by blocking water and provide a better condition. But ASR is hard because it comes from inside.
So basically these equations are quantification of the ASR expansion, and the ASR expansion is a major issue in the concrete structure. Several researchers are trying to find out the actual chemical kinetics in the concrete structure, because it is not possible to see or do any exact experiment on the concrete microstructure. So basic idea is to develop several governing sets of equations based on those chemical kinetics and quantify the expansion mechanism in the concrete structure. So I hope this will be applicable in any kinds of concrete structure, so that they can predict and quantify the damage if the concrete is under the ASR expansion.
So that we scanned more than 30 types of aggregates or cement or even lunar soil particles, just extracted geometry of individual particles and then save it to a database. And later on we come up with an algorithm to generate the new microstructure and then form virtual cement concrete.
If you want to build a concrete structure in an environment that has sulfate and that has temperature variations, then you can see how the concrete gets damaged over time and how long your concrete can survive over there. If you, let's say, put some extra materials that can provide extra protection to your concrete, then you can simulate that with this model and you can see how long the concrete will survive.
The current ongoing autonomous driving vehicle is the platform that I'm really proud of. The initial goal to design this platform is to test our develop the AI model.
We thought there should be a better way than manually measuring all the cracks on the road. We took an RC car and modified its upper portion. We picked NVIDIA's Jetson board and Raspberry Pis for 2 different systems. So one of the system does the automated driving part and the other one does the detection part. It is possible that they will automatically analyze the data and send it to a web server so that we can monitor the whole road system. We collected 6,000 sample images from our track, and I have annotated them and labeled them to train basically a neural network model. So when you feed a picture into it, it will detect where the cracks are.
I think he's working on the non-destructive testing. Basically, he's working on 2 topics. One is infrared imaging, thermography. The second area of Aiding's work is ultrasound, using a non-destructive testing equipment called ultrasound array, phase array technology to detect the in-depth failure.
The idea of thermography is that when you heat up the surface, whether it is active thermography or passive thermography, it's gonna emit radiation, and this radiation reaches the camera and the camera converts it to temperature. We induce some artificial defects inside the concrete domain in different shapes and in different depth to be able to see what is going to be the effect of depth on inspection of the surface of the concrete. And since the area that is affected is going to have a higher temperature on the surface, so we could see where the defects are located and how good it is going to be detected using the thermography.
theoretical understanding of the material phenomena and then make it resilient and sustainable for our infrastructure system. Another area is the application of sensing and non-destructive testing technologies to collect the data and provide decision support for our infrastructure system.